of light when it enters the triangular prism, is it not? So what we have learned? We have learned that whenever a ray of light enters a glass prism, equilateral prism, then the light ray will undergo some deviation and there will be change in the path of light. That we have discussed. And the angle of deviation also depends on certain factors, and we have discussed in detail how the angle of deviation changes with the velocity of light, wavelength of light, and also even refractive index of the medium through which light is traveling. Now, apart from that, we have even learnt about dispersion of light, is it not? So, when we were discussing about dispersion of light, what we have learnt, see, when a white light is incident on a glass prism or an equilateral prism, then what is happening? This white light will split into its constituent colors. And we know that white light is consisting of 7 colors, is it not? And which are those 7 colors? Violet, indigo, blue, green, yellow, orange and red. Now, white light when it is travelling through vacuum or air, the speed of all the colors remains the same. But when it enters transparent medium like a glass, then what happens? The velocity of all the various colors changes. The velocity of violet light is different, the velocity of blue light is different, the velocity of red light is different. So depending on the velocities of the different colors, the deviation for different colors also takes place. Now, already as I have told you, there will be 2 refracting surfaces for a prism. This is AB is one refracting surface, AC is another refracting surface. Now, at the first refracting surface, that is AB, what is happening means the white light will undergo dispersion, means the white light will split into its constituent colors, and apart from that, even deviation will also take place. Understood? So, at the first surface, deviation is taking place and also dispersion is taking place. Okay? Whereas at the second refracting surface, dispersion will not take place, only deviation will take place or refraction will take place. Now I have shown in the diagram, the dotted line shows the original path of the white light, whereas the white light splits into 7 components or constituents, and all these 7 colors will be dispersing, and they will come out of the prism and can be caught on a screen. Now, as I have shown here, the violet color will deviate the most, whereas the red color deviates the least. Why? Because we have learnt in our previous class that this angle of deviation depends on the velocity of light. Even it depends on the wavelength of the light. Now, which color or wavelength is getting dispersed, depending on the color or wavelength of light also, the angle of deviation also changes. Okay, so here I have shown violet deviates the most, means the angle of deviation for violet color will be maximum and for red it will be minimum. And in between these 2 colors, we will have other colors also. Now, with Gaya, that is all the 7 colors have been named in certain order. And you should remember that whenever you get all the 7 colors on the screen, violet will be at the bottom, whereas red will be at the top. And here you can observe that these colors, after getting dispersed, they are traveling towards the base of the prism only, is it not? And as I have told you, this Vidgaya is called the visible spectrum. Why? Because this spectrum is of visible light. Visible light means the light which enables us to see all the objects around us, is it not? Light is electromagnetic radiation, and in that visible light means the light which helps in photosynthesis, the light which enables us to see all the objects around us, that is called visible light. And this spectrum is of visible light, so it is called visible spectrum. And what is the wavelength range we have learned? Wavelength range is 4000 to 8000 angstrom units. Now next, we should know what is the cause for dispersion. So the main cause for dispersion is the change in the speed of light with wavelength. So, as we have discussed in our previous class, the different factors which are responsible for dispersion is change in the speed of light with wavelength. As the wavelength changes, what happens to the speed of light? The speed of light also changes. And depending on the speed of light, the angle of deviation also changes. Okay. Now we have to remember certain important points here. Dispersion takes place at the first surface. See, this is the first surface of the triangular prism. Always remember that dispersion will take place at the first surface of the prism only. Next, deviation occurs at both the surfaces. This, apart from dispersion, deviation also is taking place. Here only you can notice that violet light is getting deviated by certain angle, and even red light is deviated by certain angle. And when it enters the other refracting surface, here also deviation is taking place, is it not? So, the light is bending, violet light or red light, it bends further. So, further deviation takes place at the second refracting surface. So, remember, dispersion takes place at the first refracting surface, whereas deviation takes place at both the refracting surfaces. And you should also remember that any prism can just split the constituent colors but does not produce any color of its own. Understood? So this is about deviation of light through a triangular glass prism and the phenomenon of dispersion of light. So how we can define dispersion of light? The dispersion of light is defined as the phenomenon in which the white light splits into its constituent colors when it enters a transparent medium like a glass. And the 7 colors which are obtained due to dispersion of light is called the spectrum, is it not? And it is called the visible spectrum. And as I have told you, this dispersion of light was first discovered by Sir Isaac Newton. Okay, please copy this diagram and also the points. Okay children, next let us study about electromagnetic spectrum. So, you should remember that the visible light, it consists of 7 colors and hence it is called polychromatic. Poly means many, chroma means color. Okay, so white light consists of 7 colors and hence it is termed as polychromatic. Now, we know that the sun is the main source of all the electromagnetic radiations. Even we have learned that light is an electromagnetic wave because light does not require any material medium, it can travel through vacuum also, is it not? So, the energy which is coming from the sun, it consists of many other radiations apart from visible light. So, now we have obtained the knowledge of visible light already. Visible light, as I have told you, what is the wavelength range? The wavelength range is 4000 to 8000 angstrom units. Now, apart from visible light, the energy that is coming from the sun also consists of other radiations, and all these radiations together can be termed as an electromagnetic spectrum. Okay, so here I have shown the diagrammatic representation of electromagnetic spectrum. So here is the visible light where we have all the 7 colors from violet to red. Now, beyond the violet light, we have some radiations, and beyond red also we have some radiations. And all these radiations are invisible to us. So, I have written here the part of the spectrum. So, this is the electromagnetic spectrum, understood? And this is the visible spectrum. Okay. The part of the spectrum beyond the red and violet extremes. Beyond red, we have certain other radiations. And beyond violet, we have certain other radiations. All these radiations are not visible to us, and together all these radiations is termed as electromagnetic spectrum. Okay. Now, which are the components of electromagnetic spectrum? So, in the center we have got the visible light. We know that the wavelength of violet is very less, is it not? So, what is the wavelength of violet light? It is just 4000 angstrom units. Now, less than 4000 angstrom units, we have other radiations which are very less wavelength. Those radiations are ultraviolet rays, X-rays and gamma rays. Okay. And red is having the longer wavelength in visible spectrum. Beyond red, we have other radiations which have longer wavelengths. We have infrared radiations, microwaves and also radio waves. So, all these radiations together is called electromagnetic spectrum. And we know that light is an electromagnetic wave. and it travels with the speed of 3 into 10 to the power 8 meter per second in vacuum. And we have already learned that the speed of light is denoted as c. C is equal to f lambda. Right? C is equal to f lambda. Now, if you observe the schematic diagram of electromagnetic spectrum, you can see that as you go from gamma rays to radio waves, there will be increase in the wavelength. So, which radiations are having the maximum wavelength? Radio waves are having the maximum wavelength, and least wavelength gamma rays are having. Now, on the other hand, as the wavelength increases, there will be decrease in the frequency. So, in this order if you come, it is increasing frequency. Radio waves have got the least frequency, whereas gamma rays have got the highest frequency. So, among all the radiations, which is having the least wavelength, gamma is having the least wavelength and very high frequency. And of course, visible spectrum also we have learned. Each color will have certain wavelength and it will have certain frequency also. And there is no sharp boundaries between any of these electromagnetic radiations. Like there will be some wavelength range for ultraviolet rays, wavelength range for X-rays, wavelength range for gamma rays, infrared, micro and radio waves. Even frequency range also will be there, but there is no sharp boundary which separates between one electromagnetic radiation and the other electromagnetic radiation. Only approximate boundaries can be drawn between any two radiations. So, this is the schematic diagram of electromagnetic spectrum. Please note down. And what is the formula which we use to calculate the velocity of light? C is equal to f lambda. So, this formula can be used to calculate the velocity of any electromagnetic radiation. If you know the frequency of the radiation and wavelength of the radiation, then you can calculate the velocity of that particular radiation. Understood? Now in your textbook, if you just observe your textbook, there is a table which lists out the wavelength range and the frequency range of all the electromagnetic radiations. And you have to just remember the wavelength range and also frequency range of all these radiations. Understood? Just approximate wavelength range and frequency range must be remembered. Okay. Next, let us come to some of the properties of these electromagnetic radiations. So now we know which are the electromagnetic radiations in the electromagnetic spectrum. We have gamma rays, X-rays, is it not? Ultraviolet rays, then visible light, right? Then infrared, micro, and then radio waves. So in this visible spectrum or visible light, the light which we can see, these are all invisible radiations. Understood? Now there are some properties which are common to all the electromagnetic radiations. Which are those common properties? And we shall just learn properties common to all electromagnetic. EM stands for electromagnetic radiations. What is the first property? All electromagnetic radiations do not require any material medium for their propagation. So, if you take all these electromagnetic radiation, then none of the radiation require any medium. Means they can travel through vacuum only. And when they are traveling through vacuum, no energy is lost. Whatever energy is carried by the electromagnetic radiation, all the energy will be transported when the radiation is traveling through vacuum. Okay. So the electromagnetic radiations do not require any material medium for their propagation. And what will be their velocity? All electromagnetic radiations will travel with the same velocity, and with what velocity they will travel? 3 into 10 to the power 8 meter per second. Okay. Now, in our lower classes, previous classes, we have learnt about various behaviors of light. Light will undergo reflection, light will undergo refraction, is it not? Just like the ordinary light or visible light, even other radiations also they will undergo reflection, refraction, diffraction and polarization. Now diffraction and polarization, these are the other behaviors of light which you will learn in higher classes. So remember, all radiations exhibit phenomenon like reflection, refraction, diffraction and polarization. So just like visible light, all the other radiations also exhibit this phenomenon. Okay. And fourth property is they are not reflected by electric and magnetic fields. So in radioactivity chapter, we have learnt that a radioactive source will give out gamma radiations when it is in excited state, is it not? So then we have learned that those gamma rays are not reflected either by electric and magnetic fields. Here gamma rays is one of the electromagnetic radiations only, and remember that any electromagnetic radiations is not reflected by electric and magnetic fields. And you should always remember, you should also remember that all electromagnetic radiations are transverse waves. So fifth property, I shall just write down here. So they are not reflected by electric and magnetic fields. What is the fifth property? They are transverse waves. Now what are transverse waves? We have two types of waves, longitudinal waves and transverse waves. Transverse waves are those waves in which the particles in the medium, they will vibrate at right angles to the direction of propagation of the wave. Suppose this is the direction in which the wave is traveling. So in this direction the wave is traveling. The particles in the medium, how they will be vibrating? They will be vibrating up and down. That is at right angles to the direction of propagation. Such waves are called transverse waves. And remember, all electromagnetic radiations are transverse waves. These are the properties which are common to all the electromagnetic radiations. So which is the first property? The first property is they are transverse waves. They do not require any material medium for their propagation, is it not? They can travel through vacuum very efficiently. Second property is they do not require any material medium. First property is they do not require any material medium for their propagation, and with what velocity all the electromagnetic radiations will travel? They will travel with the same velocity, that is 3 into 10 to the power 8 meter per second. And just like visible light, all the electromagnetic radiations exhibit phenomena like reflection, refraction, diffraction and polarization. And if you take any electromagnetic radiation, none of them are reflected by electric and magnetic fields. And remember, they are transverse waves. So these are the properties which are common to all the electromagnetic radiations. And as I have told you, if you consider the wavelength range and frequency range of all these electromagnetic radiations, there is no sharp boundary separating each electromagnetic radiation. Only approximate wavelength range and approximate frequency range can be written down for any of the electromagnetic radiations. So invertible in your textbook there is a table which will list out the various electromagnetic radiation and what is their wavelength range and also frequency range. Understood? So you have to refer that table also. In the next class, in the next session, we shall discuss about the properties and uses of some of the electromagnetic radiations and what are the sources of these radiations. Okay children, we shall continue in the next session. Thank you.